All right, so let's talk about SDN. Let's talk about software-defined networking. What is software-defined networking? Why we use or why we need software-defined networking in our network? So, before we understand the software-defined networking, that is the newer approach to manage the LAN and WAN infrastructure of any modern enterprise network. Let's talk about the traditional network. Let's talk about how we used to design the network in traditional cases and what were the challenges associated with the traditional network. So in the traditional networking, if you already know, the design typically follows either a three-tier architecture or it follows a two-tier architecture. From the three-tier architectural point of view, generally we have three layers in the design. First layer is what we call as the access layer. Second layer is what we call as a distribution layer. And the third layer is what we call as the code layer. Code layer can further be connected to the internet and the other outside the infrastructure devices. Now, we used to have like these devices, like we have one switch that is, let's call it access layer switch 1. We have one more switch, let's call that access layer switch 2. We have a few switches such as here, like distribution layer switch 1, distribution layer switch 2, and we used to connect it like in this way, like access layer switch 1 is going to be connected with the distribution layer switch 1 and 2. Access layer switch 2 is going to be connected with distribution layer switch 1 and 2. Here we used to have the end devices. They could be wired or wireless devices. We could have some sort of access points here from where we can have the wireless devices connected as well. We can have some like voice over IP devices, VIP phones, and those things we can connect at the end. Now, if similar type of structure, this is, let's say this is in one of the building. If this is first building of some campus network, and let's say there is similar type of building here as well, distribution layer switch 1, or let's call that distribution layer switch 3 and 4, and we have like access layer switch number 3, let's call that, and access layer switch number 4. We have some users connected here as well. Now, if we have to connect these two buildings all together, what we can do, we can introduce a layer in between that we call as the core layer. So core layer switch 1, core layer switch 2, and we can connect like these devices with these core layer devices as well, so that our traffic can flow from one building to the other building, from one particular VLAN in one access layer device to the other like device in the VLAN on the second building. So typically our infrastructure is designed in this three-tier hierarchical way. Some organizations, they don't have these three-tier organization, this three-tier like hierarchy. They have like two-tier architecture where we only have the access layer and distribution layer. The responsibilities of core layer were merged together in the distribution layer, and we used to call that some sort of core distribution layer. The responsibilities of, since core and distribution layer is merged together, so we used to call that core distribution layer. Now, in this type of topology, traffic like mostly follows from like south to north. It takes more of a south to north approach. Like the traffic is going to go from this machine to access layer device, from here to distribution layer. Then from the distribution layer, it will go to the, like if it has to go to the other side, other building, it will go to the core layer, from the core layer to the distribution layer to the access layer, and it will deliver it like right here. So traffic follows more of a south north approach. Now, this is in a typical campus area network. When it comes to other places such as data center, the topology might differ. Data center traditionally, like they used to follow this type of architecture, but in data center, since data centers are designed to serve the specific type of services, specific type of applications, so in data center, more of an application-centric networking takes place. So the design from the data center point of view, it is not going to follow this three-tier or two-tier design. From the data center point of view, now in the data center, it is more of a spine leaf type of architecture, where we have some switches. We call them like for example, these are the leaf switches, like leaf switch number 1. Let's call that leaf switch number 2. Let's call that leaf switch number 3. here we have the leaf switch number 4. Then we are going to connect them. We are going to connect these leaf switches with some sort of spine switches. Let's call that spine switch number 1. Let's call that spine switch number 2. And we are going to connect it like in this fashion. Okay. So in the now here we can have variety of servers that could be based on the VMware or virtual devices. So we can connect our servers or all these devices on the leaf switches. And if I had to go from one of the leaf switch to other leaf switch, the traffic is again going to follow the spine switches accordingly. So mostly like in this case, the traffic goes more of like east to west type of. When the traffic has to go from east to west, this spine leaf type of architecture is comparatively better to have. Now, in both the cases, in both the networks, like in the traditional network based on 3-tier or 2-tier hierarchy, in this spine leaf architecture in the data center environment, if in the data center environment they were still using this 3-tier, 2-tier hierarchy, so managing the devices and infrastructure is going to be a little bit complex. So what they thought of that why not we overcome those issues that we face in the traditional network, and why don't we use some sort of software defined approach to manage these devices that we have in our infrastructure. So what were those challenges that we are talking about? What were those challenges in the traditional networking? So one of the major challenge, one of the biggest challenge that you can have, it is going to be related to deployment of new devices. So let's say you already have your existing infrastructure consisting of like 2 or 3 devices, and suddenly your network growth happened, and now you have to expand your network to like 5 to 10 more devices. So you have to add 5 to 10 more devices in your infrastructure. Maybe you have to add some new switches, you have to have some new routers in your infrastructure. So what we have to do is that you have to, whatever configurations you have done on these 2-3 switches like VLANs and everything, you have to deploy all those things on these 5 to 10 devices, 5 to 10 switches if I consider as well. Like same configurations that you have done here, same like some users are going to be part of some VLAN, some users are going to be part of some other VLAN. Similar type of thing you have to do here as well. You have to configure few users in one VLAN, few users in other VLAN. You have to do all that thing. You have to install those new devices. You have to provision those new devices by yourself, and you have to then add new VLANs. You have to run the protocols such as you have to fine tune the protocols more like such as STP, or you have to fine tune the protocols such as VTP, DTP, whatever protocol you are running. So there were a few challenges based on deployment that you will face. Also, there were some challenges based on security. How security is provisioned in a typical enterprise infrastructure, it is, let's say, what we might do, we might create VLANs to separate the traffic for one user with the other user. We might have configured some sort of VLAN, and based on the VLAN, the traffic of one user cannot, go into the other VLANs. So this user cannot communicate with this user. Or we can have security based on something called access control list. ACLs, we can create like ACLs on the routers and the switches to prevent access of unauthorized users to the network. We can create the access list to block the communication between 2 or more devices. We can create the access list to block the remote access such as telnet or SSH from the unauthorized user to the devices. We can use ACLs for variety of tasks in short. So we can enforce some level of security based on access control list. We can have a lot of security appliances as well. We can have like firewalls, we can have IPS, IDS, where we can apply a lot of security policies. We can have a lot of security policies, and we can deploy those security policies from that firewall or from that IPS, IDS device that we have. Now, what if if we are extending again, you are extending your network from 2-3 devices to 5-10 devices, and maybe you are adding a new branch. You might be adding some new branches in your existing infrastructure. So what you had to do, you had to create the VLANs, you had to create the ACLs, you had to add the security appliances onto that branch as well, and you had to enforce all those policies that you have applied here as well. So as the network grow, your ACLs they do not scale that well. I would say they do not scale that well. You can have like thousands of statements in the access list, and when it comes to management of that access list, it is not going to be a easy task. So uh, security challenges were obviously there. Security challenges were obviously there where we had to enforce similar type of security policies on all the branches, on all the departments. And what we had to do, we had to do that manually. Fine. We have other operational challenges as well. Like we had different types of operational challenges as well, such as, for example, let's say we are running a campus area network. In that campus area network, same we have like access layer, we have access layer devices, then we have distribution layer devices, and we have connected all these devices with like distribution layer switch 1, distribution layer switch 2, like that. We have connected, and then further on it can go also to the core layer switches like core layer switch 1, core layer switch 2, whatever. So here we might be facing some sort of operational challenges as well. For example, a user reports that I'm not able to get the IP address via DHCP, or my time is not synchronizing with the network due to some reason, or my DNS resolution, I when I open the web page, I do not see that DNS getting resolved properly. So let's say if the user in VLAN 2 raises some sort of issue, a user in a particular VLAN 1020 raises some sort of issue, how you are going to, what approach you are going to take to resolve that issue. Let's say the user says that I'm not able to get the access to the, I'm not able to get the access to the network. Why? Because I don't have the IP address. I was supposed to get the IP from the DHCP, but I'm not actually having the IP address right now. So what approach you are going to basically take to resolve this issue? You might check the DHCP server, you might check the reachability, you might check the, for example, if you have done the routing, you will check the routing protocols. If you are dealing with the spanning tree here, like you will see if the appropriate ports are blocked or not, if the loop is there or not. So once you eliminate all these possibilities because of which the packet can drop, you might be able to troubleshoot like what exactly problem was there. So you could face a lot of operational challenges as well. Other challenges that you might face is the management of the wired and wireless users. In modern day network, we don't only have the wired users connected in our infrastructure. We also have the wireless devices, wireless users connected in our infrastructure. So how you are going to deal with those wired or wireless devices in your network? Maybe we want to have some different type of policies. We want to have some different type of policy for the wired user, and we want to have a different type of policy for the wireless user. Okay, we want to ensure that any user that comes in our infrastructure and joins our wireless network is going to be considered part of as a guest Wi-Fi network, and we want to ensure that our guest users, they do not consume a lot of bandwidth. I want to ensure that our guest users, they do not talk with our internal like wired or the other users. I want these guest users to only have the access to the internet so that they can do their daily tasks, but they are not allowed to communicate with the other departments of my organization, such as admin department or the finance department or anyone. So the management of wired and wireless users is also going to impose some challenges. Other issues that you might face in the traditional network is some sort of vendor dependency. Not from the point of view of traffic flow, because since the TCP/IP came in the market, any vendor can communicate with the any vendor. So I'm not talking about from the data flow point of view. I'm talking about from the vendor basically device type point of view. So what if like what if I think like in our core, in our like access layer, what we should have the Cisco switches. These switches that we have in our access layer, these are the Cisco switches. And now I think like Cisco switches that I have applied here at the access layer or even at the distribution layer, I don't want to have the same Cisco switches on my distribution layer or at my core layer. I want to use a switch from some other vendor and I want to connect it like this. So what if I do these all the switches that we have, these are like all the Cisco switches, and here we have some different switches. These this could be any vendor like HP or any other vendor switches we can have. So in that case, like management, how you are going to do the management of these switches, how you are going to take the management level access of these switches, the CLI or GUI of these switches or CLI GUI of these switches is going to be completely different based on what vendor you are going for. So how you are going to manage these different vendor devices into your infrastructure. Not only Cisco, you can also have Juniper based devices, you can have HP, or you can have firewall that is not made by Cisco. You can have for example Palo Alto or Checkpoint, these firewall solutions you might want to go for. So how you are going to have management, how you are going to manage all these different vendor devices in your organization. So these type of challenges, these are some examples of the challenges that you might have in your infrastructure. So to deal with these variety of challenges based on security, to deal with the challenges based on these wired management of wired or wireless user, to deal with these challenges of variety of operational issues, or to deal with the challenges of these vendor dependency or vendor lock-in issue, to deal with these deployment issues, they thought of introducing some sort of a software-defined approach to solve all these. So software-defined networking or SDN is basically an approach that they actually took to resolve a variety of challenges that we had in a traditional network. And the software-defined approach to manage the LAN infrastructure of any campus area network or any enterprise network is what they call as the access, software-defined access. The software-defined approach to manage the WAN infrastructure of any network is what they called as the WAN. And even in the data center environment, if you're talking about data center topologies where we follow some sort of a spine leaf architecture, there also we want to have a centralized point of control using some sort of application-based networking, software-defined networking. So in the data center environment, we already had ACI for a very long time. So software-defined approach to manage the data center network, actually what they do that based on something called application-centric infrastructure or ACIs. ACI was there in the data center environment for a very long time, uses the concept of VXLAN and the other to manage the data center environment. So ACI was there in the data center environment for a very long time. This software-defined access and software-defined WAN they introduced in our enterprise campus area network, so that we can have a centralized point of control. We can have centralized point of control over LAN and WAN, which is going to make all the like security related concerns, or it is going to allow us to manage all the devices from a centralized point of view. It is going to make the deployment of new devices very easy. Similar set of policies we can apply from one point to other point. It is going to resolve variety of operational issues as well, because anytime suppose a user cannot get the IP from the DHCP, the controller that we use in the software defined networking, they can give us prediction, or they can give us like what could be the reason for this problem, and what could be the possible solution, what could be the steps that you can take to resolve this issue. They have that sort of dependency. Vendor lock-in issue is not going to be there. You can use whatever type of switches that you have, and that controller that we are going to use can talk to these devices specifically, like for example traditional devices that we are using which do not support software-defined networking based on like telnet or SNMP or these type of things they can talk about. This vendor lock-in issue was resolved earlier by creating the controllers based on standards such as OpenFlow. So that was a standard that people like the organizations were using earlier, but nowadays like Cisco, if you specifically talk about Cisco, to provide the full control on the LAN infrastructure of a network, Cisco has this controller called DNA Center or DNAC. For the WAN solution, if you talk about the WAN solution, Cisco basically has the SD-WAN based on Viptela. Cisco also offers Meraki based SD-WAN. So we do have two SD-WAN solutions in Cisco. So Meraki based SD-WAN and the Viptela based SD-WAN, both we have in Cisco, which is just an just the approach of managing the WAN as devices in the infrastructure. And as far as the data center is concerned, ACI, application centric infrastructure, is already there. It has been there for comparatively like very long time period. So to resolve all these challenges, we will see how or what actually what controllers are used and how these controllers are used to resolve all these issues.